In today's lesson video, we're going to take a look at lesson 3A.3. This is a short lesson where we're going to be identifying congruent triangles and explaining what that means for triangles to be congruent. So as we look at congruent triangles, here is what we mean when we say that triangles are congruent. Triangles are congruent if they have three congruent sides and they have three congruent angles. And by that I mean pairs of sides and pairs of angles, because we have two triangles, so we will have a pair of matching sides and a pair of matching angles. We say corresponding sides and corresponding angles. So here's our first idea when we talk about congruence. Okay? Congruency statements state that one triangle is congruent to another, and it identifies the congruent corresponding parts in doing so. So if I've got these two triangles, this is my congruency statement, okay? That triangle ABC is congruent to triangle DEF. But in saying that, what we mean is that certain parts match up as congruent also. And you can see in the picture, we're going to do our angles first, that angle A is marked congruent to angle D. Well, you'll also notice that the first letter in this label is A, and the first letter in this label is D. So the order of these letters tells you which parts are congruent. So angle A is congruent to angle D. Also, angle B has a double marking, and angle E has a double marking. Because they're in the same position on either side of that congruent sign, angle B must be congruent to angle E. And finally, angle C is at the end, angle F is at the end. Well, that's why they have matching congruent symbols. Angle C is congruent to angle F. But then also our congruent sides should match up according to those as well. So when I see AB together like that and DE together, that means segment AB is congruent to segment DE. Okay? And since BC and EF are in the same order, segment BC and segment EF are congruent also. And then we have AC, as A the first one, C the last one, would have to be congruent to DF. Okay? And so the corresponding parts also match up. And you can tell these segments are congruent by their corresponding markings. AB congruent to DE. BC congruent to EF, and AC congruent to DF. And those markings match up. And so the next thing we have is this idea of our first acronym, our first set of letters that stand for a phrase, CPCTC. We're going to use that quite a bit throughout the rest of this unit. CPCTC stands for corresponding parts of congruent triangles are congruent. And that's just based on our definition of congruent triangles, that if triangles are congruent, then their corresponding parts are congruent also. And so what you see next is another situation where we are told a congruency statement, okay? And that congruency statement is telling us which parts should go together. So what I want you to do is pause the video here, and I want you to fill in these three blanks where we have congruent statements of segments or sides in this column, and then the congruent angles in this column. Okay? So again, pause the video and then try and fill out the parts that are congruent. If you need more time, go ahead and keep the video paused, but these are the answers you should get. Side AB is congruent to segment DE, BC is congruent to EF, AC is congruent to DF. So I've given them congruent markings there to match up. And the angles that are congruent, we have angle A congruent to angle D. Again, they're in the first place there. Ignore the bell. Angle A is congruent to angle D. So I should mark those like that. Angle B is congruent to angle E, so they get a double marking. And angle C is congruent to angle F, triple marking. And that's how we mark congruent angles and sides, and how we use this to identify congruent corresponding parts. And again, I could have done this without even having the picture, because originally, remember, the picture did not have anything filled in. The corresponding parts, or the parts in the same order on either side, are the parts that go together. So now let's go ahead and turn the page and take a look at congruent triangle parts and how they can be proven from different things we've learned before in previous units. Okay? I want you to remember that when we have parallel lines, that creates certain angle relationships with these transversals. So like if I have this is a parallel line to this, and we have this transversal here, okay, that creates this kind of relationship where I could have congruent alternate interior angles, like this. Okay, so angle J is congruent to angle M. Now, you could also have these congruent angles at D and E, because that could be your transversal with these parallel lines. All right? Now, you need to have these parallel markings to say that they are congruent. So I could say that angle J is congruent to angle M because of these parallel lines giving me alternate interior angles. And what we're going to lead up to is eventually trying to prove that two triangles are congruent, but I need to be able to have good reasons why they're congruent. Okay? So I have to be able to use things like alternate interior angles are congruent, but I need to know this first. Okay? And alternate exterior angles could be congruent. You're not going to see that one as much because it's very difficult to have alternate exterior angles when I'm dealing with a picture of two triangles. So you just won't see that one as much, but it's still true. And then also corresponding angles are congruent. So you might see something like this for corresponding angles, where I have parallel lines like that. Well, that gives me corresponding angles like that are congruent. Okay, and so you'll see some examples like that. We can also establish congruent angles that are vertical angles. So in a picture like this, we have vertical angles here and here. So I could say, I don't know why that went back. Let's keep going. I could say that angle C, which I can't really call angle C because there's more than one angle at C. So I'm going to call this top angle ACB, angle ACB, is congruent to angle DCE because they're vertical angles. Remember, vertical angles are these angles that are opposite from each other when I have intersecting lines. But we also have ways that we can identify that sides are congruent. Now, there's not as many ways we can do that yet, but one of the ways we can show that sides are congruent is to show that they have a common side. In these two triangles, looks like one triangle with a line through the middle. In these two triangles, they share a common side here. All right? If two figures share a side, those sides have to be congruent because they're the same line. So in this image, side DB is congruent to DB. Now, this is another reason we've learned in other proofs. This is a property called the reflexive property. When something is congruent to itself, we call that the reflexive property of, in this case, congruence, POC for congruence instead of POE. But it's the reflexive property. So those are some ways we can show that triangles are congruent. And so what we're going to do in these next few examples, I'm going to give you a picture, and I apologize if it's a little difficult to see in the video, but you've got these to go along with me in the notes. In this diagram, number one, in these examples, we want to mark the congruent sides and angles of the figures based on everything we've just covered, those three possibilities right above these examples in the notes. But also, some of the things we can look at are any given information. Anything that is given to me as congruent, I can conclude as congruent because it's given to me. So we're going to do that, and we're going to use symbols, but we're also going to explain our reasoning. We're going to give kind of a reason like we might in a proof. So as we look at example one, there's not a whole lot marked there. There's no parallel sides. There's no right angles. There's no congruent sides or congruent angles marked already. It's just the way the lines intersect. Again, sorry about the bells. As we look at this, the only thing we have to go off of is that these lines intersect, which really just gives me congruent angles that are vertical angles. So the only thing I can say to be congruent would be this. Angle ACB. Again, I can't just call it angle C. There's more than one angle at C. So this is angle ACB, or BCA, is congruent to angle DCE because they are vertical angles. And vertical angles are congruent. Okay, so that's explaining my reasoning for making that statement. And that's all I can say in this. Even though there are some that look like they're congruent, they're not always congruent. Now I've got a little bit more to go off of. I've got some more information. In example 2, similar picture, but I've included the parallel line markings. Those symbols mean these are parallel, which again creates alternate interior angles here and alternate interior angles here. Okay? So you can kind of see both of those. So these two angles were angles B and E. These two angles are angles A. Let me get that to the right color. A and D. So I've got two pairs of congruent angles. Again, I would also have the vertical angles. I'm not going to have you write that down this time because we just did that in the previous example. But these angles are congruent by alternate interior angles. So we can say angle A is congruent to angle D because those are the only two angles with those vertices. Again, the reason would be alternate interior angles are congruent. We can also say that angle B is congruent to angle E. Same reason. Okay? There we go. Don't know why my screen keeps jumping back and forth. And then the third example over on the right, again, there's not a lot we have to go off on this picture. Okay? It looks like these would both be right angles, but I can't go off of what it looks like. I have to go off of the marked information or the given information. Well, there's no congruent angles, no right angles, no parallel lines. The only thing I have to go off of is that these two triangles share that side HF. So that's all I can say. Segment HF is congruent to segment HF itself. And to explain our reasoning here, we can say it one of two ways. We can either say that that is a common side, or I can use the more technical reflexive property of congruence. Reflexive, I'll abbreviate, and then POC. So I would accept either of those as reasoning or a reason of a proof when we get to proofs later in this unit. So now as we move on to number 4, we've got a little bit more information. There's only one triangle I can see here, but I want to point out something to you. The given information, those are tick marks. That's supposed to be telling you those are congruent segments. That is always something we can conclude. I can conclude that those are congruent segments. So I can say LM is congruent to NM because that is given to me. So my reasoning is just, it's given. It's marked that way originally. But that tells me something about this triangle altogether. If I've got two congruent sides, it tells me this is an isosceles triangle. When there are two congruent sides, there's an isosceles triangle. There's something else I want you to get used to recognizing. When it's an isosceles triangle, that also means that the base angles are congruent. Okay? So angle L is congruent to angle N. Angle L is congruent to angle N because it's an isosceles triangle. All right? In an isosceles triangle, the base angles are congruent. So you need to be able to recognize that also. Okay? Next one, I've got a lot more going on with this picture, but again, you'll see two triangles here, and I've got congruent sides, I'm sorry, not congruent there. Parallel sides here and here. Okay? So since I have those parallel sides, I have this idea that I have congruent corresponding angles. So again, that was angle Q, and this other angle at S here. Again, I can't just call it angle S. There's 1, 2, 3 different angles I could use for angle S. So this angle Q is congruent to this angle S, which I could call TSU, angle TSU, because those are corresponding angles using these parallel lines. So my reasoning would be corresponding angles are congruent. But that's not all I have. In fact, I'm going to erase some of this. I also have these parallel lines which creates corresponding angles here as well. So this angle U is congruent to this other angle at S, which I could call angle QSR. So I'm going to say angle QSR is congruent to angle U for the same reason. Corresponding angles are congruent. And then finally, our last example picture here, we've got another two triangles here. We've got congruent sides marked, and I'm going to go ahead and have you mark that. I'm going to say that WX is congruent to ZX because that is given. Okay? But we also have that they share this side. So I can also say that XY is congruent to XY because they have that common side. Again, I could write common side. Or I can, again, use the term reflexive property. Either one of those is fine. Doesn't really matter which one. So this is going to be very important information that we carry over to the next lesson. After this video, you will have a short assignment where you will enter your answers in Canvas. So make sure you go back and rewatch anything you need to, look at your notes, and you should be good to go.